This is Algebra Lesson 8-2, Multiplying and Factoring. Now, we've used the distributive property before to simplify things, so we're going to simplify a couple of problems here, and that's going to lead us into understanding how to multiply other polynomials. So, excuse me. If I distribute the 4 into the 6 plus 5x, making sure I distribute it to all the terms, 6 times 4 is 24, plus 4 times 5x is 20x. Letter B here, we have to distribute a negative 8. Make sure you distribute the negative, and you can rewrite it as negative 8 times 2y plus negative 8 times 1, if that helps you. So 8 times 2 is 16, so this would be negative 16y minus 8. Letter C, just because the number's at the end doesn't mean you can't distribute it. Same way. If I do 6 times 5b, that's 30b, minus, oops, forgot my b, minus 6. And last but not least, if I distribute a negative 2 through 4x minus 1, that is negative 8x plus 2. Now, we've been doing that kind of distributing all year. Now, what we're going to do today is we're going to talk about how to multiply monomials to another polynomial and how to reverse that process. So the rules for multiplying monomials and the distributive property can be used to multiply a monomial and a polynomial. We have to remember the rules for exponents. Please remember your exponential rules, which is what we learned in Chapter 7. Okay, so if I'm going to take 4b and I'm going to multiply it by 5b squared plus b plus 6, that means I'm going to take this 4b and I'm going to distribute it to each part of this polynomial. So that's going to be 4b times 5b squared plus 4b times b plus 4b times 6. So if I multiply this out, 4 times 5 is 20. B times b squared is b to the third. There are no numbers in the middle term here, so 4 times b becomes 4b squared. And 4b times 6 becomes 24b. And that is my final answer there. Right, now you can write it out or you can distribute using my little arrow system here. Just remember to watch your signs. So negative 7h times 3h squared, negative 7 times 3 is negative 21. H to the first times h to the second becomes h to the third. Negative 7 times negative 8 makes positive 56. H to the first times h to the first becomes h to the second. Negative 7 times negative 1 is positive 7, and there are no h's, so we just tack that h on the end. So we get 21h to the third plus 56h squared plus 7h, and that's in standard form too, which makes it nice. The last problem here, number 3 in this section. I'm going to multiply negative 2g times everything. I'm going to rewrite this again, negative 2g squared. I'm going to multiply that by 3g to the third plus negative 2g squared times 6g. Minus, I'm going to do plus negative 2g squared times negative 5. So negative 2 times positive 3 is negative 6. G to the second times g to the third becomes g to the fifth. Negative 2 times positive 6 is going to be negative 12. G to the second times g is g to the third. Negative 2 times negative 5 is positive 10. And then I just have a g to the second there. So as you can clearly see, we're just using the distributive property and the property of exponents, making sure we add our exponents properly. Now, factoring a polynomial reverses the multiplication process. Okay? We know this as division, but there are two types of division in algebra. There is division of a polynomial called factoring, and there's the division by long division, which we call polynomial long division. You won't get into polynomial long division until you get into Algebra 2, but we will be working with factoring a lot this chapter. To factor a monomial from a polynomial, you first have to find the greatest common factor, otherwise known as the GCF, of its terms. So we're going to take a look at a couple of problems, and we're going to look for a GCF. So how to do that? If you're not really good, some people are going to see the GCF right off the bat. Others are not going to be able to see that as easily. So I will show you one way to find a GCF in case it doesn't come to you really quickly and you're not looking at a problem going, oh, I know the GCF of this problem is blah, blah, blah. So if I look at 2x to the fourth, I'm going to break this down to prime numbers. It's going to be 2 times x times x times x times x. 10x squared, well, 10 is 2 times 5 times x times x. And then negative 6x is going to be negative 1 times 2 times 3 times x. Now let's pair up or group up everything that they have in common. So what do all three terms have in common? They all have a 2 in common. They all have an x in common, and that is it. There's nothing else that they have, all three of them have in common, because if you're going to look for the greatest common factor, it has to be common to all three terms. If it was a four-term polynomial, it would have to be common to all four terms. So here we have it all common to all three terms. Would be the GCF then is going to equal 2x. Problem number 5 here. So I'm going to have 4b to the third, which is going to be 2 times 2 times b times b times b. Negative 2b squared is negative 1 times 2 times b times b. Negative 6b is negative 1 times 2 times 3 times b. So all I did was break it down to prime factorization. Now I'm going to group up what is common. Okay, so I have a 2 here. No other numbers in common. I have a b here and no other b's in common. So my greatest common factor here is equal to 2b. If you notice, the greatest common factor is the largest number that will divide evenly into all your coefficients, and the greatest number of times your variable shows up in any one monomial. So if I look at number 6 here, if I want to use that idea, okay, if I want to use that idea, I can look at this and say, what number divides evenly into both 5 and 10? What's the largest number that divides evenly into 5 and 10? Well, that would be 5. And what's the greatest number of variables I can take out? Well, the greatest number of variables you can take out is the smallest number that appears in any one monomial term. So if I look at this, I have a g to the fifth and the g to the third. The one that shows up the least amount of times is g to the third. So that's the greatest number of g's I can take out is g to the third. So my GCF is 5g to the third. So you can either break it down into prime factorization, or you can think through it logically. Either one, they work quite well. Once you know what the greatest common factor is of something, then we can actually factor it. Once you find the greatest common factor, you can factor it out of the polynomial. So let's take a look at factoring out a monomial. So in other words, we're taking a monomial out of a polynomial. So if I look at number 7, 4x to the third plus 12x squared minus 16x. First thing I'm going to think of is, what is my GCF? Well, the greatest number I can divide into 4, 12, and 16 is 4. X shows up 3 times in the first term, twice in the middle term, once in the last term, so the least number of times it shows up in any one term is once. So my greatest common factor is 4x. So now I'm going to take 4x to the third plus 12x squared minus 16x, and I'm going to divide each term by 4x. That's what factoring out means. It means you're taking and dividing each term by 4x. So as you can clearly see here in this first term, my 4's cancel out. X to the third minus x becomes x squared. In my middle term, 12 divided by 4 is 3. X squared minus 1, or x to the second minus 2 minus 1 is 3x. And then negative 16 divided by, my x's cancel here, and negative 16 divided by negative 4 is negative 4. But we also have to list what it was that we took out. What was my greatest common factor, which is 4x. So if you factor out a 4x out of 4x cubed plus 12x squared minus 16x, you're going to get x squared plus 3x minus 4. If you take the greatest common factor and distribute it back through, you should get back to your original problem. So I'm going to check this. If I take 4x and multiply it through everything, 4x times x squared is 4x to the third. 4x times 3x is 12x squared. 4x times negative 4 is negative 16x. This should be the same exact problem I started with, which it is, so I know I must have factored it correctly because it checked. Let's take a look at number 8. Number 8, my greatest common factor between 8 and 12. 2 goes into 8 and 12, but 4 also goes into 8 and 12. So the greatest common factor here is going to be 4, and again, it's an x. So I'm going to take my 8x squared minus 12x. I'm going to divide each term by 4x. I took the 4x out first. 8 divided by 4 is 2. X squared divided by x is x. Minus 12 divided by 4 is 3. X divided by x cancels out. So I end up with 4x parentheses 2x minus 3. And this last problem here. Greatest common factor between 6m to the third minus 12m squared minus 24m. Well, the largest number I can divide into 6, 12, and 24 is 6. Largest number of variables I can take out is 1m. So if I take 6m to the third minus 12m squared minus 24m, and I divide each term by 6m, I take the 6m, because that's what I took out of it. 6 divided by 6 is 1. M to the third divided by m is m to the second. Negative 12 divided by 6 is negative 2. M to the second divided by m is m. Negative 24 divided by 6 is negative 4, and my m's cancel out. So we end up with 6m parentheses m squared minus 2m minus 4. And that's how we even multiply and factor monomials times a polynomial, or factoring out a monomial. So our closure question for today: how are multiplication of polynomials and the factoring of polynomials related? How are they related? How is multiplying and factoring polynomials related?